On this episode of the podcast, I have with me Sergei Azernikov. He is the VP of CAD CAM software development at Glidewell Dental. We're going to be talking about impacting productivity and consistency in dental lab products. And actually, we're going to talk about GenAI a lot. It might be surprising that we're going to be talking about dental lab products and GenAI, but I think you're going to be surprised as to the extent and duration and impacts that Sergei is going to be talking to us about. Sergei, thanks for being on the show.
Well, thanks for having me.
Awesome, man. Glidewell Dental. Obviously, you guys are in the dental space, but what do you guys specifically do there?
Glidewell is one of the largest providers of patient-specific products, and definitely in restorative dentistry, it's a very known name, even though people outside of the industry may not be familiar. We do thousands of custom products every day. It's actually over 10,000 custom products every day, which includes implants, bridges, crowns, sleep appliances, and everything dental. And we're located in Newport Beach, California, which is not maybe not the natural place for such a massive manufacturing facility, but we are here, and we're doing everything here in this very campus.
Awesome. All right. Well, I'm excited because when we spoke, we were talking about GenAI, and you mentioned some of what you guys have been doing. And I think what struck me as really interesting is how long you guys have been leveraging, advanced technologies like this within the dental space. And again, I think dental lab products, a lot of people might not frequently need them. I know I went to the dentist, and the experience was, I think last year was radically different. And I was kind of mind blown with the technology being used and how they, do all the mapping of your mouth and whatnot. But why don't you tell us, you guys have been using AI, GenAI for a while. Give us a little bit about that history and whatnot.
Right. So I get that question all the time. It's the first question when I tell people that I'm working for a dental company. They say, and I'm working on AI, machine learning. They kind of puzzled, like what AI has to do with the dental lab. They think about moms and pop shop where people make crowns by hand, and that's how the industry used to be years ago. But today it's very different. It's actually very technology intensive. It's not just AI. It's a lot of tools that are used in advanced manufacturing that we're employing here. But today we will focus more on the ML AI side. We've been again, because of our scale, it's a 5,200 people enterprise with thousands of unique cases done every day. We were looking for ways to automate production, to make it again more consistent, to increase our throughput, and it turns out that machine learning shines in that space where we have a lot of data, a lot of different cases, anatomically different. Even one person doesn't have two identical teeth, but they're close enough to be able to find some common ground and some algorithms that can be flexible enough to cover that variety while maintaining this consistency and high throughput. So we actually started thinking about this back in 2015. When people started talking about neural networks in computer vision and other spaces, and we started from a very simple question that we asked ourselves: can we train a machine to identify teeth? Right? It sounds like a trivial problem for a trained person, but for an untrained guy like myself, when I came to this industry, I didn't know anything about teeth. So if you would show me a tooth, I maybe would be able to tell if it's posterior or anterior, but I wouldn't know what tooth number it is. Is it lower? Is it upper? I had no idea. So we asked ourselves, can we train a network that could do it for us? And we even organized a competition. We took one of our best technicians, and we let it compete with the neural network in identification of teeth. And you can imagine what happened. Obviously, the machine was accurate 100%. And a human, even a very highly trained human being, was making mistakes. So at that point, when we understood that, this was our aha moment, when we knew that this can work for the industry. If it can identify teeth, it can do many interesting things for us, because that's the first step. When a technician looks at the case, at a particular case, he is trying to see, okay, what exists, which teeth are missing, right, and what needs to be done. So that part we knew we can do, because we can start identifying teeth, and we can then go further and start offering treatment to replace those teeth with artificial implants, crowns, what bridges, what's not. And that's where the generative AI comes in. Now, when we identified what needs to be done, now how we actually do that. So conventionally and historically, people made crowns by hand. Then somewhere around 2000s, the CAD/CAM technology started getting into dentistry. So instead of making them by hand, people were designing it still manually, but designing it on a computer digitally. And now the question became, okay, how we can automate that process, how we can make that process simpler, faster, so people don't need to actually sculpt it on the computer. And that's where generative AI comes in. Once we have thousands or hundreds of thousands and millions of cases that were designed, again, by humans, we can start learning from it and being able to generate designs automatically. And that's exactly what we've done. We've used generative adversarial networks that actually came about around the time, around 2015. And we developed systems that, using GANs, are now able to generate designs in a fully automated manner. So the designer essentially becomes a quality control person. Instead of designing the crown from scratch, it's actually looking at the crown and saying, okay, it looks good enough, we can manufacture it. And if not, they can make some minor adjustments. And that's a current process that we have in the company, and we even started offering it to other companies that are now using the technology.
Interesting. You know, I'm listening, and you were mentioning the competition, and I was thinking about teeth for a second. I don't spend a lot of time thinking about teeth, but you got me thinking about teeth. And I started thinking about how we as humans notice the most subtle nuances in our teeth. If it's a slight, if you have had a crown or something, you have a chipped tooth, we notice it. Your tongue finds it, you notice it. Your brain goes, hey, that's different. And it's interesting because as you're kind of describing what the process was for a very long time, and it is for a lot of people, of trying to model these crowns, these implants to fit. Now we're talking about a machine learning, neural network that can understand 100%. I would imagine, I guess maybe this was a question I was going to ask you later, but it just popped in my head as user experience. Most people, when they think about dentists, they don't have really great positive experiences, right? But I'd imagine people must walk out with a better fit, a better experience. They must, I had it, done with imaging, and I was amazed at her scanning my mouth and watching the rendering. And then when the crown came in, it literally popped on as though it was hand to glove, and I barely even noticed it. So firsthand, I could definitely say, but from a business, what you guys are seeing as an industry within what you guys do, are you seeing the user experience shift? Are you seeing a higher degree of happiness?
So absolutely, we see, and you already pointed out, kind of hinted to the trend of digitization in general for in dentistry. That's happening chair side. You as a patient, you experience it firsthand chair side with our doctors, and we as a company, we provide technology not only for our internal use but also for our doctors, for our customers. So what you described is essentially a digital scanning experience. Instead of taking a mold, like physical mold, we now have technology that the doctor is able to scan a patient and create a digital scan, and base the design and manufacturing on that digital input, which essentially makes the whole process fully digital. And even chairside. So it's all done in doctor's office within a couple hours. So that's absolutely a phenomenal user experience. Instead of, again, historically, you would take a mold, then the mold is sent to physically to the lab. The lab is taking time to design and manufacture the restoration. And so the typical turnaround in the industry was 2 weeks for that. Today it's 2 hours, right? So you can get everything done in one shot. And then what inevitably happened before, again, because there is a separation between doctor and the lab, there could be fit issues, right? Like you put the crown comes in, the doctor tries to put it on the patient. Sometimes it doesn't fit, so he has to adjust it himself or send for a make. That's another 2 weeks. So it's certainly not ideal user experience. So technology today at the level where the doctor can scan the patient, the scanning technology evolved a lot, so it's becoming much more user friendly. And then the design part, right? Many doctors refrain from chairside treatment because they didn't want to spend time or were just not confident enough to design the restoration by themselves. But today, because of all that automation that we brought in, they don't need to do much. They just they scan, the system designs the crown for them in the cloud, actually using our cloud service. And then it comes back to them already pre-positioned, and they just need to look at it and say, it's great, we just mill it. Or if not, again, they can make some small touches based on their preferences. But essentially, that level of how the system is streamlined and the amount of intelligence behind it allows them to do it seamlessly, quickly, and without a lot of failure, right? Without like a lot of failure modes, because most of the work is done for them, and the success rate is much higher. So, and that ultimately brings a much better outcome for the patient, much less of that adjustment or like inconvenience where the doctor needs to adjust it, and ultimately like better outcome for the patient.
I'd like to ask you about, you said having the data, and obviously, you guys have been in business for a while. Maybe talk to us about the fact that a lot of what you guys were doing was traditional handwork by people trained by people who were specifically focused on this particular process, which is super intricate, right? I mean, you mentioned the person that couldn't beat the machine. These are expert people in their field. Was a lot of this data that you guys were seeing early and from historical basis, how was this data kept? Because the reason I'm asking is other industries where you talk to people, they have a lot of data. The challenge around that might be, is it just not being a usable format? And you guys have successfully leveraged machine learning, GenAI technologies, and you've been in business for a long time. So I'm kind of curious about that.
Right. So one first problem that most conventional manufacturing enterprises tackle or need to tackle if they want to go into ML is where is the data stored? How is it stored? And is it in a form that can be actually utilized effectively? And one of the early decisions that we made, which proven to be crucial for the success, for the later success, is utilizing the cloud, the AWS. We were one of the first, or one of the earliest adopters of cloud when it just became available around 2015. Again, initially we were all on-prem. I think as everybody else, we had servers where we stored data. Now, I'll make even one step back. The Glidewell started looking into software development, developing its own infrastructure and software because of the sheer scale. They started using third-party software, but it wasn't able to deal with that scale that we have. And it started from storage. Like if we have, again, thousands of cases a day, you need to have a very well-organized storage databases. And if it's all on-prem, you have to manage all these hard drives. And it's been the whole other level of complexity that the company had to deal with. And So the decision was made, okay, since we cannot use products off the shelf, we need to develop something on our own. And very quickly we realized that the storage is one of the biggest challenges. So, and then again, coincidentally, the cloud came about, or maybe not coincidentally, because many people realized that's a problem and they need to do something with it. So we adopted cloud, and now we have more than a decade down the road, we have millions of cases stored in the cloud in a way that is easy now to harvest for machine learning and AI, creating all these generative models that are very data hungry, as you can imagine. We can easily create, because of the elastic computing and elastic storage, we can create setup where whatever number of data points a researcher needs, we can provide it, and in a very effective way, a very cost-effective way, and very quickly. We don't need to go around and search for hard drives and look where actually those cases are. We have a centralized storage location where all our cases are stored and categorized. We have different ways of searching for those cases, right? We can easily create queries that will go and find just the right data that we need, because it's even just the nature of our data is challenging. It's not just text data, right? Not textual structured data as most most companies deal with. It's actually a 3D patient-specific data stored in certain 3D formats, right? As meshes, right? So it's not even obvious how do you categorize those cases? How do you in an effective way? How you search through them? If we need to find cases with certain geometric or anatomical traits, how do you actually do that? So we have developed ways to analyze those cases. We do automatic segmentation, right, as part of it, so we know exactly what each case contains, which teeth are missing in each case, and we store the data so we can later easier traverse through it and find just the right cases that we're looking for that particular task that we're trying to solve, right? So there are many different considerations, but at the end of the day, I would say cloud was the big enabler for us, AWS, and we have a great partnership with them. We've been doing, like I said, we are very early adopters, and we've done certain things with them. Without it, it would be very much more difficult to do. But we have also had to, since we were such an early adopters, we had to do certain things on our own, even though later on those tools became available, but we had to develop it on our side. For example, storage for networks, right? Like once you develop the network, you need to host it somewhere. Today, there are many mature systems on AWS and others that like SageMaker, for example, right? It's one of the most known and mature technologies today. And people, if you want to do something with machine learning, you most probably will host it there. But when we needed it, it didn't exist. And so we had to develop our own hosting solution to solve our network, to store our networks for efficient inferencing, and we still use it because it's more cost effective for us. But today, I would say today the entrance into machine learning and AI is much simpler than it was in 2015, because there are many technologies already mature, and you don't need to reinvent the wheel from scratch, which we had to do back in 2015, 16, 18.
Interesting. I guess now that you guys have been seeing, it has been a number of years you guys have been going through the experience of it. Initially, you might have had some early thoughts about how it could impact the business. Maybe talk about what you envisioned was the business enabler, and now what are you seeing? Just because you do have this, since you mentioned multiple years of experience with this kind of advanced technology.
So if I look at the progress that we've made from the time we started, almost more than a decade ago, I'm looking at the throughput, which is the most important measure at the end of the day. Like how many cases a person was able to process back in, let's say, 2015 and today. And we see that the throughput increased at least X3. And so the person was able to make X number of crowns a day. Today, they can do 3 or 4 times more on average. Right? There are some high performance, low performance, but on average, that's what we're seeing. So it's already impacted our business tremendously. We're able to make more with same number of people. Because we realized that at some point we could not scale anymore with people here, because even the parking becomes an issue here in this area. We don't have enough space, we don't have enough room for everybody. So it actually makes us to think, how do we scale with technology instead of scaling with people as it used to be. So for me, that is the biggest impact on the business, and then that's how we will continue. We will gradually introduce more sophisticated technologies into all aspects of our business. Somebody said that we electrified it, now we're going to cognify it. So this is what we're doing. We're trying to put more intelligence behind our digital processes, so we can be more efficient, more consistent, and ultimately, at the end of the day, it's all about quality products that go to our doctors and end up in patients' mouth.
Very cool. I love the use case, because I would bet you a lot of people listening that are not familiar with the space would probably be surprised that unless they've seen it firsthand at the impact, at the depth, and also the amount of time that you guys have been working with this. And I guess one of the questions I asked you was because, in a lot of the health medical field, I constantly hear executives say tons of data, and there's always a but, because a lot of the clinical notes, the information that people want to access from reports, they're all stored somewhere still, potentially on paper, or not in formats that were really meant to be consumed by a machine yet, because maybe it's digitized, but still doesn't have much value. It's just digitized. So it's a very interesting use case where you guys, through a very manual process, have gone through, and I like it how you electrified the process, and now you're cognifying it. So very cool. Sergei, if somebody has, I know we didn't, there's probably a ton of technical things that you can get into the weeds. I know we did not cover that. If somebody wants to continue the conversation with you, what's a good way of touching base with you?
So the easiest way, I think, is through LinkedIn. It's very popular today. You can easily find me on LinkedIn, my first and last name, Sergei Azernikov. And yeah, I'm always open to continue the conversation if somebody's interested in what we're doing. I think it's not a very natural field for somebody from machine learning or computer science field to think about, but when people kind of get into it and understand the sheer scale of this and the type of problems we solve, it actually becomes pretty interesting.
Absolutely. We'll make sure we include that in the show notes, because I really do think people might be curious to kind of pick your brain on the technical side of the house. And I really do appreciate your time. Thank you for being on the show.
Thank you, Amir. It's been a pleasure.
Awesome. That's it for the episode. Be back again, different guest, different topic. Till then, 2 things. One, I think Sergei gave us a great background and kind of view on how you can leverage, we'll just call it advanced technologies, because not everyone needs GenAI, but an advanced technical solution in a field where you just might not have ever thought. The advancements are there, but just shows you narrow views of applying this technology. GenAI, machine learning, can have incredible impacts. Please share this with somebody else who is potentially out there and within their industry thinking of doing similar things. I think Sergei and his story about the progress has been amazing. So share that with others. Also, like, subscribe, comment. Let me know how the podcast is going for you. Until next time, thank you and goodbye.